Hey people, I'd like to borrow some of your time and talk to you about my project on machine learning coursework, classification of Twitter user as bot or not. So we are gonna start the presentation by talking to you a little about social networks, which is gonna be followed by the motivation behind picking up this project, which is gonna be followed by me explaining a little bit to you about the problem that we're trying to solve. I'll give you a brief overview of the data set that we used and the manipulations that we did. And then I'm going to talk a little bit about the algorithms that we used and the models that we generated and the results of those. And we're going to wrap this presentation by talking a little bit about the future work, and that should be it. I like to wrap everything within 5 minutes so I don't take much of your time. So, social media networks, as it's pretty evidenced by our usage pattern and the usage pattern of millennials and current generation of people, that we consume a lot of data, and most of the data that we consume is from social media sites, being Facebook, YouTube, Twitter, etc. So it's predicted that by 2018, one third of the world's population would be active on social media sites. Twitter being one of them, it's like one of the leading social media networks based on number of active monthly users. According to some statistics, 500 million tweets are tweeted on average per day. The motivation behind picking up this project was had its roots in the basis of fake news. Based on a study conducted in 2016, the impact of news shared, tweeted, and injected by fake bots is pretty evident. It was evident in the current US elections. It was evident in the Brexit votes that happened, and it is being used to target communities by generating certain news, and then targeting communities to portray and to improve some political motives. So the problem, the problem which we are trying to solve is we're trying to detect if a Twitter account is bought or not based on Twitter user statistics that we collect from Twitter API. So I'll talk to you a little about the data set that we're using right now. So the data set consists of Twitter accounts and their various attributes. It consists of approximately 1056 bot accounts and 1076 user accounts. The dataset was collected and was a collaborative process of the entire class, and it has multiple features, namely ID string, string name, extended profile. Does it have how much friends they have, how much followers they have, etc. So we pre-process and clean the data and try to remove the noise as much as possible, and then we perform data extraction of certain attributes which could not be used as it is, like created at, we cannot use it as it is, so we converted into a datetime format from the object format that was there, and then extracted the age out of it, which was useful to us in our model prediction. Some of the attributes that we used had to be normalized and standardized to improve the accuracy, like the friends account and the followers account could run into millions, and so it was impossible and it was actually affecting the models. So we normalize those data set, those attributes in the data set, and then use the data set. I'm giving you here's a brief overview of the data set that we're using. So it has ID strings, is what's the screen name, what's the location, what does the description does it have, how many followers does it have, how many friends does the account have, etc., how many times it has been listed. So we used, for our model generation, we used three algorithms, one namely being random forest, followed by gradient boosting algorithm, and third being adder boost algorithm. We also use decision trees and naive classifier, but the accuracy was pretty bad to begin with. So these classifiers were used because they are susceptible and not susceptible to noisy data and have superior classification basis compared to other algorithms that used for noisy data and misclassified data. So for random forest, while worked on, we used the standard approach of taking the whole set and then dividing into 80 and 20 parts, 80%, 20 parts, 20% was used for testing the data set, and 80% was used for training the data for the machine learning model. So while we trained it for random forest, we got the precision score as 94%, accuracy we got as 93.87%, recall we got was 94.83%, F1 we got was 93%, and the AUC score was 93.99. Here's the ROC curve on right beside it. Similarly, for gradient boosting algorithms, we got the accuracy as 93% and the precision at 90%. The F1 score and recall score were 92.5 and 94.9% respectively, and the AOC score for the gradient boosting algorithm for that particular run of the model and that training set was 93.4%. AdaBoost had less accuracy as compared to other two because it is known and it tries to boost up misclassified labels. So the accuracy for accuracy for the AdaBoost algorithm for that particular run was 88.9%, precision was 88.8%, recall was 87.5%, and the F1 score was 88.1%, followed by the AUC score of 88.8%. Here's a brief overview of all the accuracy, precision, recall, etc. that we figured out on all and in a tabular format for your excuse me, for your convenience. So as we can see, random forest gives us much better accuracy as compared to gradient boost and AdaBoost. Also followed by, here's a screenshot of the Kaggle challenge that we are having, and my score based on certain metrics that I used. I use an ensemble of random forest followed by a 3-layer fully connected layer of neural networks, and I got a score of 98.955%, which is third, I believe. 99.6 is the first ranking, 99.3 is the second ranking, and 98.955 is the third one. So now we'll talk a little bit to you about the future work. So one of the major problems that we had, and we could not train deep neural networks on this training data, was because we didn't have much data to begin with. 5,000 data and 5,000 rows of data is not a good varied data set to begin with, but we tried and we succeeded in the base. One of the reasons could be because the test set we got such high accuracy was because the test set was biased towards being bot. There are certain attributes which were pretty much evident in bot accounts, which was not so much evident in user account, which helped boost the accuracy a little bit more. So we can use for future work, we can collect more data. We can introduce features like NLP for NLP features like lexical diversity of tweets. We can gather the amount and use those features like how many amounts of tweets that the account is doing per day, number of time it's retweeting, the average length of the tweet that he does. Does it reply to a conversation? How many retweets it does? How many replies it does, etc. So these are certain attributes that we could extract and use it. So that was all about the presentation. Thank you and have a nice day.